spend a lot of my time building security features in Cloud Dataproc, which is, if you're not familiar, our managed Hadoop and Spark offering on Google Cloud. Joining with me today is Larry McCay. He is from Cloudera. He's got over 20 years of overall security experience, including 7 in Hadoop security. And he's currently the PMC chair of Apache Knox, a system that provides a single point of authentication and access for Apache Hadoop services. Also with me is Julien Phalip, solutions architect at Google Cloud. And we're going to chat today about securing your data lake, specifically around securing your data lakes that are based around the Hadoop platform and the Hadoop ecosystem. So I'm finding 3 main reasons why customers are building data lakes on Google Cloud. First of all, there's just a lot of new sources of data coming in from a variety of places: streaming applications, IoT, device data. And that just means there's a lot more unstructured data around that you have to deal with, secure, analyze. The second reason is that folks are building data lakes on GCP is that just data is becoming a lot more self-service now. IT departments, they're getting away from this idea of having a centralized reporting team. And I think there's a lot of reasons for that, but the primary one is simply that data now is just becoming way too important to wait on all the inefficiencies that are typically imposed by teams like that. Also, the tools for working with data, they're becoming a lot more mainstream and easier to work with. So you're also finding business users that are a lot more data savvy. And the third reason is that users now need access to a lot more data than they used to, a lot more ranges of data. At the same time, businesses are getting a lot more stringent privacy regulations, and they want to protect their PII trade secrets. And so companies, they need to start automating a lot of those privacy checks and data access because you just can't keep up with all of the different sources. Most of the talk's focus today that we're about to do is on this third reason, but we also find that to satisfy the first 2 reasons, oftentimes this is a requirement to help with number 1 and 2. So customers are using Google Cloud Platform to build data lakes because we have a lot of those tools that are commonly found in data lakes. So whether it's data ingestion, data processing, data management, or data security, GCP probably has an option for your use case. Now, I can't even begin to scratch the surface of all the different offerings that you see on this slide in this talk, but what I am going to try to do is I'm going to try to answer for why security-minded customers like yourself are choosing GCP to secure their data lakes. So the GCP platform as a whole, we have independent verification of our security, privacy, and compliance controls. Google undergoes independent third-party audits on a regular basis to provide this assurance. So this means that an independent auditor has come in and examined all of our controls in all of our data centers, in our infrastructure, and in our operations. And so the certifications that we tend to go after, these are going to be the most widely recognized, independent, and widely accepted security standards. So you're going to find things like ISO for our security controls, and cloud security, and privacy. But then you're going to find things like our SOC 1, 2, and 3. And all of these certifications, having these in place, what this really helps us do is meet industry standards like PCI or like HIPAA. And we're going to continue to expand the list that you see here with certifications globally to make sure that we can help our customers meet their compliance obligations. Now, another reason why security-minded customers choose GCP is because we have deep and wide features that make it easy to keep your data secure. So we have default at-rest encryption. If anyone here has ever had to deal with doing like a LUKS encryption on drives, you know sort of the pain both from a performance and management perspective, aspects of doing that. And so Google Cloud, anytime we land data, it gets encrypted. And that just kind of makes it easy. But at the same time, you can often control the keys. So if you want to have customer managed encryption keys for that data that's stored, you can do that. You can rotate those keys on your schedule, revoke those keys as you need to. Most of our products also integrate with Stackdriver. That's going to offer you a single pane of glass for your data access and audit logs across all the cloud products and even other clouds. Stackdriver can integrate with other clouds as well. We also have OS login. If you're not familiar with that feature, that lets you take a Cloud IAM identity, translate that into a Linux user, and the big benefit there is that you don't have to be handing out and managing SSH keys to get into your virtual machines. We also have VPC service controls, which is going to give you the ability to do a lot of the things that you're doing in your on-prem networking stack in Google Cloud. And then we also have Cloud Identity and Access Management, as well as Kerberos support and Dataproc, and I'm going to talk a little bit more about those in a minute. But before I do, I want to come back to some of the data lake commonalities that I'm seeing. So I think between the three of us, I think we've seen countless data lake implementations from a variety of industries. And at least me personally, I don't think I've ever seen two that were alike. Have you guys ever seen two customer data lakes that were exactly alike? No. So, but there are three, common elements that every data lake's got to address: ingestion, storage, and then a compute platform that's going to let you use a variety of tools to mine and identify workflows. So from my perspective, at least ingest, that tends to be all over the place. Data is now coming in from just everywhere, all sorts of volumes, all sorts of velocities. And even like in my GCP world, I've seen a lot of common tools, but a universal pattern I've not seen for ingest yet. However, when it comes to number 2 and number 3, where you store the data, and then having a platform for tools, customers do tend to answer these in the same way. So in cloud storage, at least in Google Cloud, is the store for the data lake. It's the hub that brings together GCP around your data. It's going to check that box for most of those features that a data lake storage system is going to require. You're going to have high durability, centralized security controls, storage classes that help you optimize cost, and one very relevant for Hadoop and Spark is we have immediate consistency. Now, that's a really important feature that allows you to use cloud storage as a drop-in replacement for HDFS without adding a bunch of workarounds like NoSQL databases. And so once customers land on cloud storage and they've identified that as their storage mechanism, the next step is typically trying to identify a way to manage and mine and identify all those various workflows. More often than not, customers always choose a platform over a specific tool that lets them run a variety of open source processing applications. You really need a platform that can provide lots of and the latest capabilities. So Cloudera and Cloud Dataproc both provide these platforms. Cloudera is focused on building a unified hybrid cloud, where Cloud Dataproc, we tend to want to modernize your stack and pull you into the Google Cloud platform. Yet, because both of us are working on so many of the similar capabilities and in the open source community, we were able to come together and build some common security infrastructure that we both could use. So in a bit, Larry and Julien are going to talk a little bit more about that collaboration. But before I hand off to them, I want to leave you with some IAM best practices for data lakes. So just to back up and just baseline Cloud IAM, it is who can do what on which resources. So you're typically going to have a project owner. They'll invite members to projects. Then they're going to grant them roles. And then those roles, those consist of a collection of permissions for one or more resources. Some basic IAM best practices. You want to definitely follow the principle of least privilege. That applies to identities, roles, and resources. So you always want to select the smallest scope necessary to reduce your exposure to risk. So you're not going to go and grant everybody like an owner role to your entire organization. There's intentional hacks or mistakes that could bring down applications. You want to be really specific and deliberate and assign a specific group, like a security admin role, to manage SSL certs and firewalls on specific projects. And you want to use groups as much as possible. So dealing with managing permissions for individual users, that can be really cumbersome. It can be error-prone. So you want to use groups. You can see in this example, we have users that are getting added to a SecOp team group, and then it's that group that's going to get your permissions like security admin and log viewer. You also want to make sure that you have policies in place to secure your resources. You want to make sure you're controlling how additional users gain access to resources through policies and group memberships. Because without strict control over those policies, you might be inadvertently allowing new users more permission than they need. And then now we're back to violating that principle of least policy. Okay, at this point, maybe a lot of you are rolling your eyes or pulling out your phones thinking, yeah, Chris, I get this. This is every RBAC system ever. And there's some validity to that. But here's some important things to keep in mind that are actually different in Google Cloud. So you're going to have two members of your data lake in Google Cloud. You're going to have the accounts that might be either a Gmail or a Google address. Most likely, you're going to have folks coming from your G Suite domain. So that's going to be the folks that have a @ and then your company's name.com. And it's important to understand that GCP does not create or manage users or groups. I'm going to say that one more time. GCP does not create or manage users or groups. So the I in our IAM, that's almost a bit of a misnomer sometimes. When you assign a permission to someone in Cloud IAM, it's going on to that user, but that user lives outside of the GCP project, and they might be associated with many GCP projects, or even a different organization altogether with a different set of permissions. That's why in GCP, in your data lake, it is really important to scope things as much as possible with service accounts, because those service accounts are associated and limited to those GCP projects. So, now that we understand that users and groups are not part of your specific GCP projects, here are some data lake best practices that may not be quite as intuitive as that first set. So, your data lake objects, your GCS bucket ACLs, those default ACLs, any object ACLs as much as possible, those should contain groups. Great, we established that. But those groups, as much as possible, should contain IAM service accounts. You want those service accounts then to represent a type of automated workload. And then what you're going to want to do is grant in users the IAM.serviceAccountUser role to that service account. You also, as much as possible, the goal here is we want to avoid exposing a long-lived credential. Really avoid that if that credential is associated with a real end user. Because remember, that user, they might have other permissions that are not part of your GCP project. So let's say I'm working with Larry, and he's from Cloudera. He only has some read-only de-identified access to my data. I might think, whatever, I'll give him a long-lived credential because it doesn't really matter in my project. But if it is with his real user, he also probably has access to potentially in other Cloudera projects, he could be an admin. And so creating these long-lived credentials for real people, that creates almost like a somewhat ambiguous blast radius because you're not just limited to the GCP projects that you have control over for these users. And so also, as much as possible, try to use the Google APIs, things like the G Cloud, or if you're using Cloud Dataproc, use the Jobs API to break apart isolation and permissions. So the Cloud Dataproc Jobs API, that'll determine who can submit jobs to the cluster versus who has actual access to the cluster. And better yet is even if you can do isolation based on the VM or the cluster itself. And so I know I just said, that's my best practice is, isolate by VM or cluster, but I'm also very well aware that that is not practical in reality for a lot of situations, which is exactly why we do have a beta version of Kerberos now integrated with Dataproc. And this is going to let you do things like tie back your Dataproc users to Active Directory. It also makes it as simple as a button click to turn on security features like Hadoop Secure Mode or encryption in flight. Now, the standard model in this Kerberos beta is that users access Cloud Dataproc. They're going to obtain a Kerberos principal for the work that they do on the cluster itself. And then everything done on the cluster is that Kerberos user. However, if the data does need to get accessed from the data lake in Google Cloud Storage, that data is going to get obtained using the service account credentials of the virtual machines of the cluster. Now, this model works really well for customers that can lock down their cloud storage buckets, and this is really what a lot of customers want. They want all the security controls in their cluster. That lets them use tools like Apache Ranger. However, we do have a lot of customers with very stringent security and compliance requirements that actually need to translate that identity, that Kerberos identity, back into a cloud identity so the chain of access never gets broken. This is actually a security problem that exists across other cloud providers as well. And it was something that Google and Cloudera were both working to address. And so I think you now know where this is headed. I'm going to hand off to Larry now to talk about how Google and Cloudera came together to solve that dilemma.
Okay, what Chris was talking about just now is something that I've been calling the cloud identity crisis. We'll dig into what that means. Okay, so challenges for data lake identity when we're in the cloud or we're accessing cloud data. Something I call the identity gap. We'll get into each of these things. Related to this, we end up with a phenomenon called credential sprawl, and also this issue of being able to use short-lived credentials rather than long-lived credentials. So this gray area on this slide represents this identity gap. And on one side you have the Hadoop and Kerberos users, or your enterprise users, which Hadoop knows about. And the other side you have your Cloud IAM users and identities, which Cloud Storage knows about. But Cloud Storage doesn't know about Kerberos users, and Hadoop doesn't know about IAM users. So, you know, we've actually supported these cloud data connectors for a number of years, and we've had to bridge this gap. So these don't really represent points in time, but these are different approaches that have been used to try to bridge this gap, and they're all some flavor of bring your own keys, okay? So we started out using environment variables. We've had a username and password in the URL itself to have your keys. We have configuration files where you put your keys in there. We have, you know, instance profile or service accounts associated with the VM, which Chris mentioned. We added the ability to protect your keys with the Hadoop credential provider. And coming soon, we have delegation token support. So these are all attempts to kind of bridge that gap, but they led to this credential sprawl. So, you know, I have many jobs from many users running, and they're configuring their keys across your platform in various ways. How do you know where they are? How do you know where they end up? They are possibly in environment variables, not often anymore, but could be. Configuration files. They could be in credential stores, which are key stores that are across your data platform. They could end up in process listings, in log files. They could end up in GitHub repositories. So this is what I'm calling credential sprawl. Okay, it's hard to find them, it's hard to clean them up, and it's very easy to leak them. So we needed a way to address that. If you notice, I'm not saying anything about number 5 here yet. This is related to the work that we've come together to work on and collaborate on. And this introduces the use of delegation tokens, which is a native part of Hadoop. And this is the standard way that credentials are propagated across your data platform for use by worker tasks that don't have Kerberos credentials of their own, possibly, and things like that. They are securely distributed with the jobs and cleaned up when the jobs are done. They're also time constrained with an expiration time and a fixed number of times that they could be renewed within another time period. And very importantly, they're already supported in the existing Hadoop clients. So in order to introduce a new delegation token type or to introduce new sources of delegation tokens, you don't have to change any of the Hadoop clients. So this can also be leveraged to broker tokens, which we'll talk about later. So this picture, I'm not going to talk in great detail about this because Julian's actually has a nice presentation of this overall flow. But this is, the canonical picture of how delegation tokens are actually used for accessing HDFS. Okay, so a user logs in and they submit a job. The Hadoop client interrogates the file systems that are being used and tells them to go collect their delegation tokens, which then get distributed and to the worker nodes, right, and are available to those tasks while they're running. And upon job completion, they're all cleaned up. So that's essentially Kerberos for HDFS. Remember that. Okay, so open source. Open source is actually why I'm on the stage here. It's actually why I joined Hortonworks when I joined Hortonworks, and why I'm happy to still be with the new Cloudera to work in open source. So contributors to open source, not only dedicate their time and commit their time to these projects, but at the end of the day, they put their name on it. So I want to call out some people who have worked on this stuff because this is moving the platform forward, actually. So Steve Loughran, who happens to work for Cloudera, created this JIRA and this patch, which added delegation token support to S3A, which is a data connector for S3 access. He also provided an out-of-the-box implementation for those delegation tokens to limit that credential sprawl. So you can now use your keys from your desktop only, so authenticate to AWS, and submit a job, and his change will call AWS STS service and acquire short-lived session tokens for you. And they get distributed as delegation tokens with the jobs and cleaned up when the job's complete. They are short-lived tokens, and there's no real way to renew them. But it really minimizes this credential sprawl phenomenon to your desktop where you're using them. So this was a great step forward. So as we looked at that mechanism and we realized with minimal change, we can swap out the source of these tokens. And we realized we can start normalizing how tokens are accessed across all of the cloud vendor connectors. So Phil Zampino, also from Cloudera, contributed a patch back to the GCS data connector in open source. And Julien, Igor, and Chow reviewed and collaborated and improved this patch so that it works as well as the S3A patch did and meets the same needs. So that brings me to the Cloudera Identity Broker. And this is an upcoming feature. It is not released yet. The goals, essentially, if we were to boil it down, is, remember I said Kerberos for HDFS. This is Kerberos for the cloud. It's the easiest way to think of it. You log in with your enterprise credentials and K and IT as normally. Delegation tokens are acquired from the IDBroker and then later used to acquire access tokens as needed. The goals for the IDBroker itself are a secure multi-user data lake deployment in the cloud. And it's multi-cloud and hybrid cloud. Like I said, you authenticate with your enterprise credentials. We only use short-term IAM tokens. And we leverage your existing investment in Cloud IAM policies and tooling, et cetera. We also have the ability to renew those short-term tokens, so long-lived jobs will still maintain their access. So this is a simple picture of the existing kind of ecosystem of data connectors along with HDFS. And these red credentials needed kind of represents that identity gap we were talking about before. And all those many ways of filling that gap were used. But this is the picture we're moving towards now. Okay. So all the existing clients are going to talk to the data connectors and tell them to go get their delegation tokens. And transparently to the user, they're getting acquired from the identity broker, and access tokens are acquired and ready for access to cloud storage. So this is essentially Kerberos for the cloud. The same picture is Kerberos for HDFS, but it shows how the identity broker is used for acquiring delegation tokens and access tokens, and then subsequently providing access to cloud storage from the worker nodes. So in order for us to have, one of our requirements was actually to not require IAM users for every one of your enterprise users. Okay? In order to not do that, we need a way to associate roles, quote unquote. In S3, they are actually IAM roles. In GCP, they are service accounts. So we associate group memberships to roles. And we have a role selection algorithm that picks the best match based on configuration, based on these mappings, and based on a number of other things. And this is just a mock-up of what a UI will look like to do this. So kind of just to illustrate the power of this, of being able to just use your enterprise credentials, we'll walk through a simple use case of migrating data from one cloud provider to another using TCP. So you log in with your typical Kerberos KInit, and you issue the Hadoop TCP command with your source and your destination URLs. And you can see by the scheme there that one is for S3 and one is for Google Storage. Okay, so the client, as I described before, iterates over the file systems it's about to use and tells it to collect its delegation tokens. The delegation tokens are then collected from the IDBroker for both of those file systems. They're collected into the app launch context. And you can see one for each of the cloud storage vendors there, as well as an HDFS delegation token here. And Yarn distributes it along with the app launch context and the credentials in a secure manner. And during execution, those credentials are used to move the data from the source bucket to the destination bucket. And the way that it does that is it takes the delegation token and it authenticates the IDBroker, even though it doesn't have Kerberos credentials. It's using that delegation token. And it's requesting access tokens. It will also ask for new access tokens when they expire. And then as the job completes, delegation tokens are all cleaned up, and we eliminate credential sprawl completely. We logged in with our enterprise credentials, and we ended up dynamically getting access tokens for as long as we needed, but even though they're short-lived, from multiple cloud vendors, and your data is now migrated. So just kind of a summary slide here. We have multi-cloud access token acquisition for AWS S3, Google GCS, Azure ADLS Gen 2 is is still being worked on. You only need your enterprise credentials, as I said. Supports long-lived jobs with short-lived tokens, and leverages the existing support in Hadoop clients. Another thing to be aware of, which is a related but separate effort, is that we are working on common enterprise data policy across on-prem and cloud storage data access. So that's also coming soon. So I will hand it over now to Julien, who will talk about the GCP Token Broker, which was enabled by the same collaboration.
Thank you, Larry. And hi, everyone. I'm Julien Phalip. I'm a solutions architect at Google Cloud, and I'm really excited to introduce you to the GCP Token Broker. So what is the GCP Token Broker? It is a brand new open source project that we just released last week. It currently is in alpha, and I will talk to you a bit more about the upcoming roadmap. So this is the result of a close collaboration that we've had with several large Hadoop customers, as well as with partners such as Cloudera and Hortonworks. The project on GitHub contains documentation about the design that we've aligned on, as well as a reference implementation. So this project is intended for enterprise customers who are currently using Kerberos to secure their on-prem clusters, and who are looking to migrate those clusters to the cloud and try to replicate the same user workflows and experience. So this is particularly valuable for customers who are interested in a hybrid environment where they can let the users run jobs on-prem as well as run jobs in the cloud. So the main goal for the GCP Token Broker is to ease that migration. And this is done by leveraging the same Kerberos and Hadoop delegation token facility that Larry introduced to. This facility allows to securely distribute short-lived credentials across a cluster. It also allows for a seamless integration across multiple tools and frameworks around the Hadoop ecosystem. That includes things like Spark, Hive, Tez, Yarn, MapReduce, and many others. And because the integration is so seamless, this reduces the chances that you have to make when you're migrating your clusters. The broker also helps enforce AAA security. This means that users can continue to use Kerberos to authenticate. And you can also have a very granular authorization where you can set permission on individual users for specific buckets. And as far as accounting goes, this also allows you to do some very granular access logs, which is very useful for troubleshooting, monitoring, or detailed chargebacks, where you can trace back which user actually used which buckets or which resources in the cloud at what time. And the broker offers tight integration with the Google Cloud services, starting with cloud storage, in the future with other services such as BigQuery or Bigtable. So while the IDBroker that Larry talked to is focused on the Cloudera environment and to allow multi-cloud jobs to run, the broker currently is focused on the Google Cloud environment. Now, looking at the workflow at a high level, again, this should look familiar. It's trying to solve the same problem that Larry described earlier. So you have your users, your Kerberos principals, who want to use a Hadoop environment to run jobs. And as part of those jobs, they want to also be able to access cloud resources like cloud storage. Now, cloud storage like other cloud services, work with cloud identities. So what you want to achieve, basically, is you want to let your users to continue using Kerberos to authenticate and run jobs, and some way, somehow, match those identities with cloud identities so that they can then access cloud services. Now let's zoom in a little bit in that Hadoop environment to see how it all works. So now the system revolves around this broker service. There's a prerequisite that you need to set up first. That is to use the Google Cloud Directory Sync. It's a tool that's been around for a long time. What it does, it will sync your LDAP on-prem identities over to cloud identities. This is done automatically. It will sync all of your users and groups. Once you have all of your identities synced in the cloud, you can then write standard IAM policies for those users and groups and dictate what those users and groups are allowed to access. In a Hadoop context, typically this will mean setting permissions on GCS buckets. And then once that's in place, your users are ready to submit jobs. So here is Alice, a Kerberos principal. What Alice will do first is to log in by running the kinit command with the KDC. The KDC is backed by your LDAP database. And also, very importantly, the broker is also connected to that same KDC so that it will be able to authenticate your users further along in the process. Then, now that Alice is logged in, she can submit a job by using a Hadoop client. First thing that the client does is to contact the broker to ask for a new delegation token. The broker at this point uses Kerberos to authenticate the user, make sure that that user is who they claim to be, and then generates a new access token and return that, a delegation token, and return the delegation token to the client. The client then submits a job to the YAML resource manager and passes along that delegation token. The YAML resource manager, the first thing that it does is to send a renew request to the broker, just to make sure that it has full authority over that delegation token. And then the job is effectively submitted across a cluster over multiple tasks. As those tasks are running, at some point in time, they might need to access cloud storage, whether to read a file or write a file. When a task needs to do that, the first thing that it will do is to contact the broker again, this time by pulling the delegation token from the secure context and sending that delegation token to the broker. The broker then verifies that the delegation token is still valid, and if so, will then call the Google OAuth API to generate a new access token for the cloud identity that maps to the Kerberos identity. That access token is then returned over to the task, and the task can then access cloud storage as that cloud identity. So Alice, the cloud identity. And then at the end, when the job is complete, the YAML resource manager will call the broker one last time and call the cancel endpoint. This will effectively make the delegation token inoperable so that it cannot be reused outside of the context of this job. So from the very beginning, the token broker was designed with scalability in mind by using several fully managed products on Google Cloud. That includes Kubernetes Engine, Cloud Data Store, Cloud Memory Store, Cloud KMS. Now, let's look at how this all fits together. Where you can see here in the top left corner is the broker environment. The broker service is running on Kubernetes Engine, and then you can scale that cluster up to however many nodes as you need to bear the load that's required for your users. The state is stored in a database on Cloud Data Store, which is a highly scalable NoSQL database and fully managed on Google Cloud. That state includes the delegation token and also some session details that are attached to the jobs that are currently running. There is a cache currently using Redis on Cloud Memory Store to improve performance. Cloud KMS is used to encrypt any sensitive data. So for example, before caching the access token, those tokens are encrypted with KMS. And every operation done by the broker is also logged in Stackdriver, so you can monitor how the broker is used. Now, looking at the top right corner, this is your client environment. This is where your Hadoop clusters will be running, and you can choose to run it either as a self-managed cluster on Compute Engine, or you can also use Dataproc, which is Google's fully managed Hadoop and Spark service. A couple of configuration setup that you have to do. First, you need to set up a two-way trust between the client machines and the broker service. This is to allow services like Yarn that are running on the client machines to access the broker, and also to allow logged-in Kerberos users to also access the broker. And then you also need to set up a one-way trust between the broker and the LDAP database. This is so that the broker can authenticate your users. And then you can have your data be hosted on any number of buckets as you need. What you can see here with the dotted lines are separate VPCs. All of those VPCs are private VPCs. All of those machines only use private IPs, and you can then interconnect those VPCs in different ways by using VPC sharing, VPC peering, or VPNs. So this, I want to emphasize, is only an example deployment. The project on GitHub contains Terraform scripts that will allow you to automatically deploy this architecture, but you should just use that as a starting point and adapt it potentially to your production environment as you see fit. And then you can also swap out any of those components. So if you choose to use, for example, MySQL, a MySQL database to store the state, you can totally do that and replace data store, for example. Or you can also use Memcache instead of Redis. Quick word on the roadmap. So this current alpha release contains support for cloud storage and also supports Kerberos as the authentication backend, and also supports proxy users, which is a Hadoop concept that allows services like Hive, for example, to impersonate other users. In the upcoming beta, we're going to focus on performance optimizations and on stabilizing the API. And then in future releases, we will add several more features, most prominently by adding support for BigQuery and Bigtable. So I invite you to look at the project on GitHub for more details about the design, the roadmap, as well as the actual implementation that you can then try out and use in your environment. We would really appreciate to get the feedback. We want to make sure that we can implement all the features that you want and need. So please feel free to try it out and get in touch with your sales team at Google. And then we'll be sure to follow up and make sure that we iterate and make it better for you. So yeah, thank you very much. This is the end of the talk.